Hey everyone, so today we're going to be talking about solving a system of equations using substitution. So we all know that substitution means to replace. Like whenever you have a substitute teacher, you have a replacement teacher. Or if you play team sport, you might get substituted out for somebody that plays that same position as you. So today what we're going to do is we're going to take one of those equations and substitute it into the other expression to be able to solve this system. So the first thing is that we have to look for an equation that's already solved for one of the variables. It either has to say x equals or y equals. And right now, even though it's a little blurry, we have an equation that says y equals 3 plus x. And I'm going to circle that part of the expression because we know that 3 plus x is the same thing as y. What's going to happen then is I'm going to put in 3 plus x in where y is in that top equation. So I'm going to say x plus, and instead of y, it's going to be 3 plus x. And that whole thing equals 5. Okay, now I have one variable that I need to solve for. I substituted what y was to make sure I got one of the same thing in the equations. So right now, I got x plus 3 plus x equals 5. Now I have to combine like terms and combine my two x's. I got a 1x plus a 1x. That's going to give me a 2x. That 3 doesn't combine with anything. It's by itself on that side of the equation. The only things I can combine on the same side are the x's. So I'm going to say 2x plus 3 equals 5. Now this should look familiar, and I got a two-step equation that I can solve here. So I'm going to do my minus 3 to get rid of the 3 that's with the x, get the thing furthest away from the variable first. So I'm doing minus 3 from both sides. So I got 2x equals 5 minus 3 is 2. And then I'm going to divide everything by 2 to get my x alone. So I got x equals 1. As part of my answer. This is only the very first part. I have to plug this number in, this value in, into the equation or into the expression that I circled and get what y equals. So I'm going to say then y equals 3 plus 1 or y equals 4. When I write this as an ordered pair, x equals 1 and y equals 4, I'm going to write x first, then y. Remember, x coordinate, then y coordinate. So my solution, or my ordered pair, is going to be 1, 4. Now, these numbers I can plug back into the two original equations and see if they work. So I can say 1 plus 4 does equal 5. And does 4 equal 3 plus 1? Yes. So that works. That's my solution. Those answers that what x and y equal work for both equations. So that means that's the solution. When those two values work in both things, my solution is 1, 4. When we did the solving by graphing, you would see that if we graph these two equations, that's where my point would intersect, is at the point 1, 4. Here's another example. This time we have x solved for. So we got 3x minus y equals 4, and x equals 4y minus 17. So this time I'm going to put in 4y minus 17 where I see x in the top equation. So instead of saying 3 times x, I'm going to put in, or substitute, 4y minus 17 in where x is. So it's going to be 3 times 4y minus 17 minus y equals 4. Okay, now I have to do a little bit more work to do my solving, but you can see I only have one variable I need to solve for now, and that's y. So I'm going to say, do my distribution because I got to get rid of my parentheses first. So I'm going to do 3 times 4y is a 12y. And 3 times 17 is going to give me or negative 17 is going to give me a negative 51. I still got my minus y right now, equals 4. Okay, now I can combine like terms that are on the same side of the equals. I got a 12y and a minus 1y, so I can combine those two things. So I can say 11y minus 51 equals 4. Now I'm down to my two-step equation. I can do my plus 51. 4 plus 51 is 55, so I got 11y equals 55. Divide by 11, and you get y equals 5. Okay, but remember, I'm not done. I have to take this 5, this value of 5, and plug back into the original where I got circled already and say 4 times 5 minus 17, that's what x equals. So 4 times 5 is 20, 20 minus 17 is 3, so x equals 3. So my solution is going to be 3 because x comes first, 3 comma 5. So let's write that out and say 3, 5, and we can check. Okay, so if I put in 3 for x, 3 times 3 is 9, 9 minus 5 is 4, that works. 4 times 5 is 20, 20 minus 17 is 3, so that one works. So my solution, or the parts that work, are 3 comma 5 for this one. Okay, 2 more examples here. Every time we're going to use substitution, we're already going to have one of our variables solved for. So again, I got one of my variables solved for here, and I got y equals 4x and 3x plus y equals negative 21. This time again, I have what y equals, and it's just the expression 4x right there. Okay, so I'm going to plug in 4x in for y and say 3x plus 4x equals a negative 21. We'll solve them for this one. This one's not so bad. Our combining of like terms is just going to be the 3x plus 4x because they're on the same side of the equals. So I'm going to say 7x equals a negative 21. Divide by 7 to solve, and I get x equals a negative 3. Now remember, I'm not done. I have to plug that negative 3 into that equation, or into that expression that I circled. So I got y equals 4 times a negative 3. Or y equals negative 12. So whenever I write this as an ordered pair, it's going to be negative 3, negative 12, because the x part comes first. And then I can check. Negative 12 equals 4 times negative 3. Check. That works. 3 times a negative 3 is a negative 9. Negative 9 plus a negative 12 is a negative 21. So that one checks out too. So here's our solution, or here's the answer that makes that solves that system of equations. Those two equations, negative 3, negative 12, makes that true. Alright, last example here. So we got y equals 2x minus 2 and 2x plus 3y equals 10. So again, I already got one of my variables solved for. I got my y solved for. That's the same thing. Y is the same thing as 2x minus 2. So I'm going to substitute 2x minus 2 where I see y in the bottom equation. Okay, so I'm going to say 2x plus 3, and instead of y, I'm going to put in that 2x minus 2. And that equals 10. Okay. Now again, I have a little bit more solving to do this time. I got to do some distribution, and then some kind of combining of like terms, and then get my two-step equation alone. So first things first is I'm going to do 3 times 2x and 3 times a negative 2. I'm going to do that distribution. So that 2x is going to stay out there. And I got 3 times 2x is a 6x. And 3 times a negative 2 is a negative 6. That all equals 10. Now I'm going to combine my like terms. I got a 2x and a 6x on the same side of the equals that can get combined. So 2x plus 6x is an 8x. That minus 6 doesn't combine with anything, so that's still on that side, and that equals 10. Now I got my two-step equation solved, so I'm going to do plus 6 and get 8x equals 16. And then I'm going to divide by 8 and get x equals 2. Alright, almost there. Now remember, I got to plug that 2 in into this part where I get what y equals. So I'm going to say y equals 2 times 2 minus 2. A lot of 2's right there. Alright, so 2 times 2 is a 4. And 4 minus 2 is 2. So our solution this time is going to be 2 comma 2. And I can plug in. So 2 times 2 is 4. 4 minus 2 is 2. That checks. 2 times 2 is 4. 3 plus 3 times 2 is 6 equals 10. 4 plus 6 equals 10. So that one checks. So our solution to this problem is 2, 2. Okay, this is solving a system by substitution, which means we're going to substitute one of the expressions in, get it to be able to solve for one variable, and then go back with that value that we have and find the other variable that we didn't solve for.